In this lesson, I will be discussing about FCS or frame check sequence field and Ethernet frame. I also casually refer to it as checksum field. FCS field is used to identify if there has been any corruption during transit, and it is done by calculating a checksum on both transmit and receive side and comparing it to check whether the values match. If the values match, that means there has been no corruption, and if they don't, that means during transit something bad has happened that has resulted in corruption of the data. Let me explain this concept using the same workflow that I have been using in the recent lessons. I will take an example of IP protocol at the network layer. The IP protocol creates a packet and the packet is pushed down to the data link layer. The data link layer creates a frame. And here, what is depicted here is the fields that we have learned so far: the DMAC, SMAC, type, and data. At this point, the data link layer at the transmit side calculates a checksum. And the checksum is calculated on or with the help of DMAC, SMAC, type, and data field. And for that, it uses an algorithm which is known as CRC32. You don't have to understand or go into the details of the CRC32 algorithm. For now, it is good enough for you to remember that it uses an algorithm which is known as CRC32. So, after the output of CRC32, we get the result, what we can call it as result of checksum on the transmit side, and let us say it is X. This is what has been calculated on the transmit side. But now the same value has to be somehow communicated to the receiving side. And for doing that, we have the FCS field. So whatever we have calculated on the transmit side is now put into the FCS field. The field comes after the data field in the Ethernet frame. Okay. Now this frame is finally complete. So the frames of Ethernet frames are DMAC, SMAC, type, data or payload, and the FCS field. Now once this frame is ready, it is pushed down to the physical layer. The physical layer will receive the frame and will convert the frame into bits. These bits are then transmitted across the physical medium. On the receiving side, the reverse process takes place. The physical layer receives the bits, it converts the bits into frame, and the frame is pushed up. The data link layer now at the receiving side will repeat the same operation again. It has received the frame and it is going to calculate its own checksum, and it will do the checksum calculation on the exact same fields as was done by the data link layer on the transmit side. And let us say the outcome of this checksum is Y. So X was the value that was derived on the transmit side. It was placed on the FCS field and sent across. And now on the receiving side, we have the value Y. The next step is to compare these values, whether X is equal to Y or not. And if the values do not match, that gives an indication or a clue that definitely there's something wrong happened during the transit and the frame has got corrupted. And if it is corrupted, that means it is of no use and it needs to be discarded or dropped. But if the values match, that means whatever is the value of x is equal to a value of y, that means nothing bad happened during the transit, and whatever had been sent has exactly been received on the receiving side, which is ideally what we want to happen. Now when this happens, then we can use the frame, and then we move to the next logical step, which is checking the DMAC value and comparing with my own MAC address. And if they match, then move on to the checking of the type field. What is the value of the type field? Check to identify which layer 3 protocol the packet has to be passed on to. And in this case, since the type field was 0806, it is passed on to the IP protocol on layer 3. To summarize the FCS workflow, keep in mind that the checksum is calculated on both sides, the transmit and the receive side. The transmit side communicates or conveys its value using the FCS field in the Ethernet frame. Okay, and the receiving side refers to that value and then compares with its own calculated value. Characteristics of FCS. FCS is used for detection. It cannot be used for correction of errors. The size of the FCS field is 4 bytes and it is placed at the end of the Ethernet frame after the data or payload field. And the algorithm used for FCS or for the checksum calculation is CRC32. Now, we have been referring to this all along. Using the previous lesson, we learned that the type field falls between the SMAC and data here. And now the checksum field or the FCS field is going to be at the very end after the data field in Ethernet frame. That completes our complete Ethernet frame.